This video lesson is on normal distribution part 2. We are going to be talking about the empirical rule, also known as the 68, 95, 99.7 rule. So the first thing you need to know is that we have this thing called the empirical rule, and you might sometimes hear it called the 68, 95, 99.7 rule, which is a lot of numbers. But the real thing that we care about is that we know those percents. So I usually will say the empirical rule, but we do need to actually know these numbers, and these are going to be percents. Basically what this states is that for normal curves, and remember our normal curve is that bell curve shape, we can assume that most of the data, 99.7, which is almost 100%, is going to fall within 3 standard deviations from the mean. So let's remember from last time that the mean is always in the middle, and then we can count up 3 standard deviations and down 3 standard deviations. And now there are more standard deviations that we could go. We could keep counting up 4, 5, and down 4 and 5. But the reason we usually stick within these 3 is because almost all of the data is going to fall between those 3 standard deviations. Other than some of those outliers or the really high people or the really low people, you're mostly going to be in here. So the first piece is that 68% of your data is going to fall within the first standard deviation. So that means from -1 standard deviation to +1 standard deviation. So between, right around the mean, left and right, up and down. The next piece of information is going to be that 95% of the data falls within 2 standard deviations. And then lastly, 99.7% is within 3 standard deviations. So what this is going to look like is we have our normal curve down here. I would put the mean right there in the middle. That's always where our mean goes. And then I would add 1, 2, and 3 standard deviations up, and I would subtract 1, 2, and 3 standard deviations down. And again, I can always put the +4 and the -4 standard deviations. So the first piece is saying 68% is between negative and +1 standard deviation. So if both of these areas is 68%, then that means that 34 is going to be each of these blocks. So think about the fact that it's 2 pieces here adding up to 68. So it's almost like we're going to divide it by 2. And by almost, I mean actually. So we're taking that 68 and we're dividing it by 2. Now we can see that each of these 2 big blocks is 34. So what I'm talking about is not the piece above the curve, but strictly all this stuff below the curve. So the area under the curve is what we're talking about. So the next piece is going to be 95%, and that's falling within 2 standard deviations. So 95% of our data is between those 2. So now we need to do a little bit of math to figure out what this chunk and this chunk represent. And remember, it's symmetrical, so both of those green squiggles are going to be equal. So if we know that 95 is all of this, then I'd want to take that 95 and get rid of the 68 that we've already talked about. That's going to give us 27. And then I would divide that by 2, and that's how I'm going to find each of these pieces. So 27 divided by 2 is going to be 13.5. So each of these green squiggles represents 13.5% of the data. And these are percents, and that's something that I don't want you guys to forget. So these are all percents. The last piece is that 99.7% falls within 3 standard deviations. So now I'm going to take that 99.7 and subtract the 95 we were just dealing with. And so these 2 little yellow chunks right here are in total 4.7%. So if I divide that by 2, then each of these is going to be 2.35%. Now, because we have only 99.7% represented here, everything below that third standard deviation below and everything above this third standard deviation above in total is going to be 3% of the data. So everything below, not necessarily within 4 standard deviations, but truly everything this direction and this direction in total. So we can say that this is going to be 0.15 and this is going to be 0.15 because we do still know that it's symmetrical, even if it is higher than 4 standard deviations above. So now let's do an example. On the last Algebra 2 test, we found that our students' scores represented a normal curve. That's important to know that it's going to fit this model here. We also found the mean to be 80, so I'm going to throw that in the middle, and the standard deviation is 5. So what I can do with this standard deviation is then go and add up 5 onto each of these lines, and then I'll go the opposite direction. So I'm going to subtract 5 going down here. All right, so what we know is that 68% of the data is going to fall within these first two. So 68% is these two pieces right here, between 1 standard deviation below and above. So that 68% is between 75 and 85. So we're saying the average of this test was an 80. So that means most people, 68%, a good chunk, scored between 75 and 85. Next up, we're talking about 95% of the data is going to fall between the next section. So we already have the 68 that's been talked about, but 95 is going to be between 70 to 90. So we said 68% was within 1 standard deviation. We now have 95% between 2 standard deviations. So in that third chunk, 99.7 is going to be within 3 standard deviations. So that's going to be between 65 and 95. So now let's kind of extrapolate it. Let's figure out the percent between 85 and 90. So here's 85, here's 90. We know from what we just did above that that piece there is going to be 13.5. So when I do these problems, I don't love to think about the 68, 95, 99.7. I prefer to memorize 34, 13.5, 2.35, and 0.15. I find these to be more helpful values than the 68, 95, 99.7. Because this, if we break it down like this, we can just add stuff up as opposed to having to rebuild this whole model from that 68, 99, 95, 99.7. So let's memorize these numbers. That's my big tip to you guys. Okay, let's talk about what percent of students scored below 75. So I'm going to find 75, and I want to add up everything to the left. So that means this is 13.5, this was 2.35, and then that last piece was 0.15. So if we add all of that stuff up, we're going to get 16%. Our last question here is talking about the percentage of students higher than 85. So I'm going to find my 85 right there, and I want to add up everything to the right. So that's going to be, again, 13.5, 2.35, and 0.15, which is another 16%. So all of these answers were percents, whereas the answers to the first three were the data values. So these were test scores. This is the percent of the test scores. Next up, we're talking about z-scores and how those work. So on our Algebra 2 test, students' scores represented the normal curve. We know this. We know the mean. We know the standard deviation. We want to find the percent of students below 82. If we look back at this curve we built, 82 is randomly in the middle of this. It's not quite on a perfect thing. It's not going to be a perfect 1 standard deviation above. So we need to use our calculator for this. We cannot do this using the empirical rule. So if we want to find the percent of students below 82, we want to find that area under the curve. We need to find out what is to the left of 82. So we would find 82 on our curve, and we would try to figure out what is all of this percent underneath 82. And since we can't find it just by looking at it, we're going to need to go to desmos. So in order to find some percentages for our normal curve, we're going to go to Functions, Distributions, Normal Distribution. So this is normal curve. It's a distribution of data. Notice how it says the mean is 0 and the standard deviation is 1. We want to change that and put our mean of 80, comma, standard deviation of 5. Now what we're finding is this probability. And notice that there's just this green line on the screen. I don't want to see that. I want to see the curve. So I'm going to click on this plus, that little zoom button. And the total area under the curve from negative infinity to positive infinity is 1. That means 100% of the data is represented from negative infinity to positive infinity. That makes sense. You're talking about everybody here. What we want to find is everybody below 82. So that means the maximum is going to be that 82. And notice how the curve is now only shaded for part of it. It cuts it off at 82. We want everybody below 82 to the left of it, and that's what desmos shows us here. The answer to this is this decimal, 0.655. They're giving that as a probability. We want to see it as a percent. So think about as a decimal, as a probability, it's 0.655. We're going to scoot that decimal over to find our actual percentage here, the percent of students that scored below an 82. Next, we're talking about students scoring above 76. So when we use the calculator this time, we want the minimum to be a 76. So let's go back to desmos. So I'm just going to type all that back in. And now 76 is the minimum, and I'm going to zoom in, and we can see that 78.8% is under it. Our last regular problem, we want the percent of students between 76 and 82. So that means our minimum is going to be 76, and our maximum is going to be 82. Let's go back to desmos. So I'm going to change the minimum to 76. We'll see it cut off. Change the max to 82. So now only that sliver in the middle is what we're looking at. So we're going to get 0.4. So that's going to be about 44.4% of the students were between 76 and 82. All right, our last problem is a spicy problem. We have the percent of students that scored more than 1.5 standard deviations away from the mean. So now I need to figure out what is the value, the test score value, if their z-score is 1.5. So the z-score is how many standard deviations away from the mean you are. So last class we talked about z-scores, and the z-score formula was x minus mu over standard deviation. So if we know the z-score is 1.5, because that's what this represents, we're trying to figure out this x value, the test value. So I'm going to plug in my mean and my standard deviation into this formula, and we're going to solve for the test value here. So I'm going to multiply both sides by 5, and then we're going to add 80 to both sides. So we get 87.5 equals x. So that is the test value, and we want to figure out what percent of students. So this is not a percentage, this is a test score. We want to find the percent of students that were more than 1.5 standard deviations away from the mean. So we want to know if this is the minimum value. We want to know everybody above it. So let's go back to desmos to finish this. So I want to put that 87.5 in for my minimum, and the maximum is infinity because we want everybody above that. And we get 0.0668. Now another way that we could actually do this is not actually find that test score at all. We could use our standardized mean and standard deviation, because the z-score will just be that 1.5 as our minimum. So notice how we got the same answer here. So whether I figure it out for our specific situation or whether we standardize it and use that empty normal distribution where the mean is 0 and the standard deviation is 1. So there's actually two ways to do this problem. Either way we do it, we get that same chunk of the curve and we get the same percentage.